We're back in Atkins, and the duplexes are moving along. We've made a lot of progress here. I'm joined today by Dan McGuire, who has been on previous videos. Dan's with Heartland Consultants. He's a president owner, I think, yeah. And then Todd Richardson with Todd Richardson Construction, who's the general contractor overseeing the project. And then Mike Nolan is here with us today from Horizon Original Architecture.
Sure.
Original Horizon?
Horizon Architecture.
There you go. Okay, and so Mike is here today because he's an expert on high efficiency, high performance building. He did a lot of the detail work for us, and so we're here to pick his brain. And the conversation we are going to have today, I wanted to talk about insulating basements, essentially. So we've had some discussions with a variety of people, and there's some differences of opinion about the importance of certain ways of approaching this, and I thought we could have the three of you kind of talk about your thoughts. I think historically, the way I understand it is that most people, when you think that the ideal way to insulate a basement is to put all of the control elements on the outside of the foundation. So you have your insulation, your air barrier, your water barrier, all that exterior, and then you build the house in a way that all the moisture issues, it dries to, first you keep all the water out the best you can, but then knowing that that's going to fail, probably, that you dry to the inside. And that, I think we approached it that direction. That's the way we wanted to go. The problems we've run into with doing that are two, at least in my mind. One has been, how do you protect the foam? So I wanted to get your thoughts on that eventually, but how do you protect the foam that's above grade? And we've struggled with that. And then the other issue is, how do you prevent bugs from getting into the house? Everything I read suggests that this external foam is a potential pathway for insects, whatever kind of bugs to get into the house. And so I'd be interested to know how you address that. They're obviously putting all the insulation on the inside would be easier, you know, for timing with our subcontractors, and the materials are common to everybody, and we can eliminate all these other problems. But Todd and I are very worried about doing that because of moisture problems. You know, we're just concerned about how do we build this insulation on the inside and not have issues with moisture. And so that's how I would start off, is just saying that's how I've been thinking about things, and I'd like to hear, you know, what you guys think about it. I mean, how do you feel about insulating basements, I guess?
Yeah, I mean, you pretty much outlined the two basic approaches, and we were talking a little bit about this earlier. We have, well, really two systems we're talking about here. One is going to be the thermal system, so how do I keep the heat in or out? And then the other is going to be basically my water management system, so how do I keep that moisture and water from getting in? You hit on a third, which is not as commonly discussed, which is kind of like vapor movement. And like you talked about, if I have a very good water barrier and I'm not letting any water in from the outside, and I've got a good thermal barrier, I am still going to have some moisture on the interior, either from that cement, which is going to continue to cure over time, and also just from, you know, our pink bodies in respirating and adding moisture into the environment.
Let me stop you just for a second, because I want to make sure that we highlight that, because this is something Todd and I talk about a lot. The concrete that we poured in the foundation and on the slabs is wet. Mm-hmm. Right, okay.
Yes.
It is wet. I mean, it'll dry over time.
Absolutely.
You know, 2, 3.
Over time. Yeah, it's years, not.
Right.
Yeah, okay.
So we're not talking about a massive amount of water, but I am going to be continuing to put moisture into that environment. Where you'll see it probably, Todd, is more if you go to put on basement flooring, which is where we see a lot of issues. If I put that on when the concrete's still too green, or if I don't have an adequate vapor barrier, then I'll have delamination of my flooring, things along that line.
Right.
So that's something to think about. We kind of think about like from the big down to the small issues, but managing all of those as we go through. I think you hit on the biggest one that we continue to run into, particularly from the builder standpoint, is there's an ideal spot to keep that insulation nice and in line on the exterior, which pushes that insulation to the outside. But we do run into a durability problem. There's a couple of ways to address that, either through like a galvanized metal, which is not always that aesthetically pleasing, something like a stucco flex or an EFIS type product, that also can have some lack of durability. But you do hit on a very good point, which is if you are in a termite prone area, then you have to take additional steps, and that can either be there's some detailing to put a copper flashing between the top of your wall, which is not necessarily the most economical solution, or basically to treat all around the house continually for termites.
Right.
So that's something that we've run into, and have kind of changed our thinking on how we approach this.
Yeah, that's been our approach is, we've talked about putting some kind of flashing, some kind of material, on the top of the foundation that's between our above grade wood wall and then our foam that's on the foundation, some kind of thing, bug break or whatever, a termite shield or something. But we haven't figured out how to do that in an economical way, something that we can get the trades in line with each other so it's seamless, and is not very expensive.
And there is a section in the residential code that talks about the specific detail and area. But again, it's something that it's not commonly enforced unless it's been in a problem in a jurisdiction.
Right.
But we do have in Iowa, we are in a termite prone region, so it's definitely a good thing to think about as we're building our homes, and just having that ability to kind of, for the homeowner to be aware, if, that just something to look for over time. So you kind of alluded to interior insulation then and some of the challenges with that. So that's where we talked about the two systems. We have our thermal system and we have our water management system. And then how do we start to break those things apart? The best place for your water management is going to be on the exterior, what we call the positive side. So if it's groundwater, things like that, are pushing against the basement, that's where I want to put that.
Yep.
Which is usually going to be some sort of either a membrane or a bituminous, a tar coating or something like that on my foundation.
Yep.
So that's always going to be, that's kind of a non-negotiable. It's got to be there.
Correct.
When you get to the inside, what you will, a lot of times, and I applaud you guys for looking at the insulation on the exterior. That's not something we commonly see, because most, I would say, volume builders are going to go with what we call the kind of diapers. If you walk into a basement, in most homes, it's a polyethylene wrapped fiberglass bat that's kind of draped down the walls. Maybe there's some framing, something like that there.
It's my understanding it's not called diapers because of how it's constructed, but because of how it smells.
Well, it could be.
Oh, okay.
If you ever walk in after a couple of days, you kind of reach your hand.
Yeah.
Pull out, and you're going to have probably a soaking wet hand, because the condensation back, the air that's still getting back behind that barrier, is just condensing along that wall. Without getting too far into the building science, if we think about where our insulation or what we have with that concrete is, basically I have something that has almost no insulating value. So if it's cold underground or cold outside, that's going to go directly through the concrete.
Correct.
If I have any sort of moisture or humidity inside, that's almost immediately going to, it's like you put your cold glass of frosty beverage, that frosty beverage is because that condensing of the water and the moisture is hitting that cold surface. So I'm already creating a condensation plane. So then the question is, how do I deal with that? So I can do one of two things. One is either to manage that condensation through something like a dimple mat or like an interior drainage, which is not ideal because that's going to add cost and complexity, particularly to a new build project. The other thing I can do is I can get rid of that drainage plane or that condensation and push my insulation out. And the place way we typically see that is using something like a 2 pound per cubic foot closed cell spray foam directly applied to the concrete to push that out. And then I don't have, by the time I get to the face where my moisture can get through, that's going to be, we're not going to call that a vapor barrier, but it does keep vapor from moving.
Right.
So it's kind of an all-in-one solution for that.
The way I understand that, though, is that's going to seal things off so that air isn't bringing moisture to and hitting the surface or whatever. But it also still has to breathe, right? I mean, whatever substance you use, whether it's rigid foam or spray foam, that still has to have a breathability. Is that not true? I mean, from what I've read is, you want to maintain that permeability of whatever that product you use it directly against the concrete still has to be able to breathe. Do you not think that's true?
I'm not going to say that's not true. I would say in that ideal situation, if you had something back there like a capillary break or a mat that allowed that a little bit of
Yeah.
movement for that moisture to get out. But I think what we kind of get to is kind of levels of excellence. If I can keep most of that moisture stopped to where when we talked like with the exterior insulation, I'm planning on everything to dry to the inside.
Yeah.
The other way, if I stop it here at the face of it, maybe I'll get a little bit of incidental condensation. Probably not, because there's just not going to be any
Yeah.
space for that to happen.
Okay.
Eventually, that'll work its way back into the concrete and out, which brings up another point of wanting to control where that source comes from. One thing that we don't think about a whole lot or see is from the foundation, the footing to the foundation wall, putting in basically what we call a capillary break, something
Yes.
to keep that moisture from sucking up and migrating in. That's
Right.
another big point is concrete will remain porous.
Yeah, and we've pushed hard for that detailing, and we have gotten some pushback on it. And I think partly just because people in the industry just don't do it.
That's correct.
But right, so we've been pretty careful about that stopping that capillary, or putting a capillary break between the footing and the foundation. Right. I think then the question we have had in our mind is, how much, if you do want to go on the exterior, how much foam do you have to have on the outside of the foundation so that the foundation wall isn't getting cold, and so that when your warm, moist air in the house hits it, you're not getting condensation? I mean, how thick does it have to be?
So I will say the textbook answer, and you got the book right now from Joe Stebrick of Building Science Corporation, is always going to be 40% of your insulation value in your rigid insulation, and then at a minimum 40% there, and you should be in pretty good shape. The absolute answer is you'd have to do a hygrothermal analysis, which we don't really want to get into because most people don't want to do that. But
Right.
if I have 40% or more of my required insulation value, I'm probably pushing that dew point out far enough that the concrete is also going to be fighting a little bit. If I've got warm air on the interior and cold on the outside, it's going to hit there somewhere in the middle. So when we talk about dew point, that's a place where, given the proper conditions, moisture could
Right.
condense. But if it's in the middle of a concrete wall, it's not going
Doesn't
to condense.
matter.
Right.
Yeah,
So that's probably a good rule of thumb if we're looking for.
Okay, so then maybe this is a good place to ask this question then. And Dan, maybe you'd be the best, well, I don't know best, but you'll be one person to answer this well. What is code? I mean, in Iowa, if we were in Atkins, Iowa, what is code for the below grade wall and for the slab?
Well, it depends on if you're talking about performance or prescriptive. Prescriptive is going to say R20 on the interior, most likely. Or we do performance and we do trade-off, and people have uninsulated basement walls. And they can actually do that, through that pathway. Okay. So, neither are great. I wouldn't say code is a great reference, honestly, for dealing with a basement wall.
So code, if you were doing the prescriptive pathway, would be 20, an R value of 20 on the below grade wall. And the slab would be?
Well, the slab, that's always a tough one because it's really not enforced either. So, R5 or R10, depending on your climate zone, where you're at, things like that. But you should always be definitely looking at getting some thermal bridging going on in those areas. But basement walls are just tough to insulate. They're just a tough section to do, what I think building science says we should really be doing. A lot of times what we try to do, we're kind of getting into talking about like economical ways of doing these things, is we're just kind of mitigating bad building already. And your concrete wall is also a mass wall. So like Michael was saying, the condensation happening in it is not as big of a concern because it's not dissimilar materials. They're not affected by a little bit of moisture and condensation as well. So insulating the exterior of those walls is always the best way to go, but it has a lot of issues, waterproofing, flashing them, the bug thing, which I have definitely run into, which actually probably changed my personal opinion on this, to bring that insulation inside and then just start dealing with making the concrete wall just not actually have the moisture moving through it and dealing with like that. And then, a lot of times what I like to think about is if it does happen, or when, I should say, depending on time, because time does things to buildings, right? And that is like, what are we going to do and what's going to be there? So, the diaper that we call it, the vinyl bats, which we see are really common, it's just not a long-term great strategy. We really like to I like to recommend putting in a material that is just not going to be affected by water or moisture. So, a lot of times even just 1 inch of foam will really kind of help stop any of that condensation. But if you really want the answers, it gets into the hydrothermic,
So would you then
analysis.
put foam on the outside of the concrete and on the inside? Both.
No, I mean,
Or would you just do the 1 inch in lieu of nothing on the outside?
no, I mean, if you're going to go outside, then you put it all outside. You're already dealing with that
Which one or
detail.
the other?
It's all up to you, really, right? Yeah.
That's been the debate, right?
No, I mean, why are you going to do it on the outside and deal with all the details you have to deal? Just do it all outside if you're going to do that, and then don't worry about the inside, and then you can worry about the inside for maybe noise or something like that instead.
But if you're going to go all outside and not have any insulation inside, and you're following a prescriptive path, then that's 4 inches of foam, right? Is that right?
Typically, yeah, for like a extruded polystyrene product,
Yeah.
which has a whole other level of challenges. We were talking a little bit about what we're reading. There's a pretty interesting book called The New Carbon Architecture that talks about the materials that we use in building.
Yeah.
And like one of the worst things we can use is my
XPS.
I mean, it works, it's great, but so how do we solve that problem and also keep that in mind? Another point with the exterior insulation is a lot of time, to Dan's point earlier about thermal bridging, is I'm going to take that exterior insulation down to the footing, then I'm going to jump across a piece of concrete, and then maybe I'll pick up with my under slab insulation. So I've created a direct thermal pathway there. We do, one of the designs we do is for passive house, which is people say that, we say that and builders kind of run.
Yeah.
But one of the things, the tenets of that is if I take a section through the house, so if I cut just right down through it, I got to be able to draw all the way around where that insulation line is without picking up my pencil.
Correct.
So a lot of times what we'll do with that is we'll put the under slab insulation and we'll turn that up a little bit. So I'm actually floating my concrete on top of the insulation. And that's a case where I do want to have my insulation on the interior. So I'm picking up that thermal boundary at the interior of the wall.
Right.
And there are products, Superior Wall is a good example. It's a precast.
Yeah, I was hoping you would talk about that briefly, because I think you're the only one that has a fair bit of experience with that. So.
It's something, it's a precast, pre-insulated product. So it's, they build it at precasters and they have 2 inches of insulation foam in it and it has steel studs built into it, but that has a continuous insulation envelope. It sits down, it typically just goes on a compacted gravel.
Right.
It takes some of the footing away. What that allows me to do is there's a little toe at the bottom of that. I put my foam insulation into the slab, and by the time I pour that, I have a continuous insulation boundary through. So that's one where we're seeing everything on the interior.
Right.
From insulation standpoint.
Yeah. Okay.
So I think, to the question really is how am I creating a bad situation by putting all the insulation on the interior? And I think the answer is got to be it depends is how I'm doing that. So where the systems would have rigid insulation and would go, and you'll see that sometimes where it's glued. But how, I guess the really question is how tight is that bond between the insulation and that foundation wall?
Right.
So the insulation, pretty much anything I'm going to put on there is going to be a vapor closed system. So my pink board, my XPS, most of my EPS is not going to allow that vapor to move either way. So where is it getting out? And to a certain extent, if it's not coming to the inside, maybe I don't really care all that much.
Okay. So it's either draining up or down or...
It'll hit that wall. If there's a little bit, even if there is a spot, sometimes we'll see voids in insulation. You might get a little moisture there. Eventually it'll get reabsorbed and work its way back. Or that concrete will kind of reach a stasis point where there's little enough residual in there that I'm probably not going to be causing problems in the long term.
Are you seeing much of it run down? Like when it becomes frosted, let's say, and it runs with gravity down and it can get underneath the foam into the basement.
If there's, insulation on the interior.
Correct. On the interior.
No. I think that you'd have to have so much moisture that's in there, and also I'm getting a little bit of heat that's going through is going to be in that spot. So is it going to be 32 degrees at that point? You have to remember that the ground, for the most part, is going to be 50 degrees plus on the. So I'm not really going to have a spot where I'm freezing. It kind of, will it not happen? I'm not going to say that. Could it happen? Yes. But it's, I mean, you have to, all the components coming together in that spot becoming an issue. And that's one of the, we can have that, a detail of that foundation insulation where I turn that up, turn my vapor barrier up the wall and kind of create a pathway to keep all that stuff on the outside. That's the other piece we think about is how am I doing managing my air barrier as that runs around the house.
So there are that raises two questions for me. One is the air barrier. So one of the things we like about, and maybe I'm thinking about this incorrectly, but one of the things we like about having external rigid foam on the above grade wall and having that match up with the foam on the outside of the foundation is that if we tape those seams properly, then it's easier to create an air barrier. At least we think of it. There's less caulking that has to happen. There's less detail work and all these little crevices and places. I mean, we've just found that that's easier. If you're putting your foam or either spray foam or rigid foam on the interior, now there's a lot of details that make it, I think, make it a little harder to get that air sealing. And it also, in my mind, makes it also harder to get to get all those surfaces covered. Because if we have these drop downs, spaces in the back, like the concrete wall doesn't go all the way to the top, or the inside of the windows and all that has to have rigid foam on it, I assume. So the detailing just gets a little bit more difficult, I think. So am I correct in thinking that the air barrier, to make it continuous, is a little bit harder if you're putting the foam on the inside? Or I suppose with the spray foam, then you just spray all the way up, like the rim joists and all that. Is that how you solve that problem?
That's how we typically detail that condition, is continue that closed cell spray foam up through the rim joist, and then starting with the above ground framing. There's multiple ways to do that. Sill seal is a great place to start. In past, we would just have somebody spend a couple of days with a case of caulk and go and just caulk up the seams. A product that I'm seeing a lot of my performance builders use now is called Aero Barrier. Each one has its pros and cons. It's just understanding where in your assembly that's happening and making sure that you have a strategy to address that. But we'll see, again, kind of going back to passive, as we talked about the thermal barrier, we talked about the air barrier, and then the bulk water management is another barrier. Products like Zip Wall will give you the option to do an air barrier and my bulk water management. Think about how do I keep rain out of the house in the same spot. That may not always be the best approach. Or if I'm doing something, thinking about where does that transfer over back to that pencil test of can I draw that continuously? And that's usually where, as we're designing a home, we're going to spend a little more time, just thinking through, well, here's a detail that we want to spend some attention to. So when Dan shows up, and started doing a blower door, it's like, whoa, we've got, we're blowing out the skirts here, not the right space to be. So all that are possible, a lot of it comes down to, as you talked about, what's conventional, what can I access in my area? Is it a labor or is it a material approach?
I guarantee you one thing concrete's going to do. It's going to get hard.
Yeah.
Two things. It's going to get hard and it's going to crack.
Yeah.
Right. So that just happens. It's the nature of it.
So you've had cracks, but you haven't had problems with water.
Well, and if prior to an occupying customer, we have in the past have found some that did leak, and we would go in and we would inject those. So it's the benefit of having that happen prior to being covered up, because then it becomes more of an issue.
Right.
Because once it's covered up, the finished basement, then also now you got to find it. You got to find the crack, and now you've got to identify it.
So that's part of my concern with even the way we've been doing things, is that even though we're putting the foam on the outside, we're still, you finish the basement. But this is one of my concerns with the spray foam on the inside as being your insulation, is that if you do have this crack that is substantial enough that there could be leakage through the foundation, have you then covered that with spray foam and you can't find it? And then does that cause a problem? I mean, that's what I wonder about.
It's hard to identify.
But is it 1% of basements or is it 50% of basements? I mean, if it's 1 in 1,000, then maybe it's not that big a deal. But if it's 10% of basements or 5%, maybe it's a bigger deal.
That all goes back to the detail of your waterproofing on the outside. Even if you're not doing the foam or anything else, that goes back to the detail that your waterproofing subcontractor, if they are doing their job, if you will, and doing it correctly, those small cracks should be spanned by the waterproofing on the outside of the house. So you should not have that get in. Now, it's not a perfect world, so
Yeah, all right.
so does it happen once in a while? It certainly can, but you have to make sure you get a good waterproofer because he's very, very important. Because like I said, if it cracks in the wrong spot, you're going to get water in there if he doesn't have it waterproof.
So the other detail then that we've noticed by putting the foam on the outside is I'm not sure how important this is, but we're able to take the waterproofing on the foundation all the way to the top.
Which is important because on a normal house, they're trying to keep that black waterproofing below grade. So if your wall cracks, guess what? It's probably going to go all the way to the top. And then there's going to be 2 feet of concrete sticking out that you're going to notice it doesn't have that waterproofing in there. So now you're having to address that too.
And that's the only place I've ever seen issues with condensation on concrete foundation walls is where it hasn't been waterproofed. And the air goes right through the concrete, it's porous. So you have something like a vinyl bat, or you have a vapor barrier over a bat material that's, up against the concrete. It's been kind of the only place I've ever seen this actually be an issue. And we've been able to solve it just by waterproofing the whole foundation.
Todd alluded to, I need to have a good waterproofing membrane. The insulation, if I think about like the spray foam, to me it's like belt and suspenders. So I've got, the insulate that on the outside. Now, if I have a few hairline cracks or a little bit of spot in here, that closed cell is not going to be prone to degradation. It's not going to be, a lot of times you see like if I put wood studs all the way against the foundation wall, well, now I've got a spot where I've got a, degradable, material there. So even that, standing those off a little bit, we know that almost every basement we have at some point is going to become living space for somebody. So thinking through how we best approach that. But how do these things work together as a system and understanding how each component.
So the details are important.
Absolutely.
Right.
Absolutely.
And I think that's one thing we've discovered over time is that there are standard ways of doing things and they seem to work fine for the most part. I think there are a lot of hidden problems. And then having somebody like you or Dan who, knows these details and knows the subtle little changes that you can make in a system to make it much more durable, more resilient, and still use the same techniques maybe. You might be using the same insulation, but you just change a detail a little bit and it makes it more acceptable, or it makes it more durable.
The principles remain the same. I mean, thermodynamics is still thermodynamics. How are we addressing that? So there's new materials, there's new methods.
New products. Yeah.
Codes catching up. We're just building better homes, which kind of brings to the point, if we could do the best job insulating the basement, but if we don't think about, how does that work with the home as a whole system, then we may be missing the boat on that. One thing we're finding, and we talked about airtightness here, is great. I got a great airtight house. How am I managing the indoor air quality now? How am I doing ventilation? Am I doing an energy recovery ventilator or something along that line? Right. So these are things that, if you recall back in the 80s when commercial code came in, we had the sick building syndrome. It's because we didn't consider that.
Right.
And I think that we're not going to make the same mistakes with residential as we get better and better at air sealing and doing a good job with our insulation. But it's something we want to think about so we don't have these unintended consequences of a really great home that now we have moisture that we've just not managed, the stuff that we're bringing in on our body.
Yeah, and I think that's something that Todd and I have come to appreciate is the collaboration with experts. We talk to our insulation person, we talk to the HVAC people, we talk to modelers that are modeling our systems. We talk to Dan as an energy consultant. We're talking to you as someone that's an architect that has an interest in these kinds of things. And then our ability to provide that product has improved over time.
I would say one big factor that goes into all this is the affordability factor. 100%. Because if the pocketbook was open to everything, we could do everything, and we just can't. Not everybody can have a certain level house, right? It's just not affordable for everybody. You go live within your means, and we're building houses. We have to stay affordable for people. Otherwise, nobody certain levels of income can get a brand new house, and then we're just going to leave them out. That's not what we're intending to do. We want to have it for the masses as well.
And maybe you'll disagree with this, but I think the number one priority with a basement is water.
Yeah,
it's probably your water control. So if you're if you're prioritizing or triaging or whatever, what am I going to spend my money? What am I going to spend my time on? What am I going to spend my detail work on? I think water is the main issue, whether that's bulk water or water in the air or water and vapor. I mean, I think water is probably the major concern. And then once you have that under control, then the other things, maybe are easier to do.
Water is always the concern. It breaks everything down. It's the solvent, so.
Yeah, because our thermal break is going to, change, how much we spend on our electric bill and some of that kind of stuff. Maybe comfort to some degree, but water, I think, is the thing that's going to destroy the building over time, right?
I mean, you're talking about three things. You're talking about bulk water, then you're talking about the thermal barrier, and then you're talking about the air barrier, and you were talking about like a red line, doing a drawing on your prints or your section for a detail of what you're building. We make projects go through that detail of that exercise almost always, and it can be a struggle. And the goal is to make sure that your bulk water line goes like this, and that your thermal goes like this, and your air barrier is inside that, depending on what you're doing. And so that's a great exercise for people out there who are trying to do this. Take that cut of the print and start drawing, and then do it on the outside too. Because one thing that we found with this program is the house to garage wall is always not under insulated or not viewed as an exterior wall, even though it really is. And so part of this program calls in some requirements for dealing with that, and it's always fun to watch that line get to the garage and stop. And then there's some duct work in that wall and some other stuff, and you can just see.
Because we've talked about that very problem in two ways. So on these duplexes, we did build the garage as if it was that common wall, as if it was an exterior wall. But the one place that we don't do that is because the foundation of the garage is the foundation of the basement. What do you read and who do you turn to for this kind of information? I think, a lot of people, and it's interesting to me to talk to even instructors in building classes and all this kind of stuff. Everybody turns to YouTube. I mean, it seems to me like that's where they go. And you can find, obviously we've been talking about Joseph Stiebrick, and he's got a YouTube presence. There are very legitimate, high quality people that you can turn to and get information on YouTube. If somebody's in their infancy in this or an expert or whatever, where do you suggest they either start or turn to get vetted? I don't know if it necessarily is peer reviewed, but vetted material that they can rely on to be reliable and accurate.
I'll give you three good sources. The first one that I like to go to is Fine Home Building Magazine, or the website. They have fantastic articles. There's a lot of technical. There's a lot of good details. They hit the gamut, but they are associated with Green Building Advisor, which is more of kind of a peer-to-peer.
Yep.
So that's a great place to start to get some conversation. You mentioned Joe Stiebrick and Building Science Corporation. Highly recommend Joe. People see, building, science. I would stay away from that. Joe is really entertaining. He writes really well, and they have a lot of kind of white papers or articles that are specifically about particular topics. And he's also very much a realist. So he kind of tells, as a passive house consultant, he calls us the over-insulate and hyperventilate people. So he's kind of strikes a nice balance. Another book which I would recommend would be Pretty Good House or Pretty Good Home. Was released a couple years ago by contributing editors to Fine Home Building, and it kind of gets into some of this of there's the code minimum home, but what could we be doing that's a little bit better, but also kind of trying to still manage affordability and expectations. So Fine Home Building is a great place to start.
And I guess I didn't appreciate that there was a relationship between Fine Home Building and Green Building Advisor, because that's one place I have turned actually, is Green Building Advisor, because. And again, maybe it's because I'm, I spend so much time on Amazon and all this stupid stuff. But is that the one thing I do like is that there's a platform for people to ask questions. So not only do you get an expert in the field to provide their recommendations for how to address this, like how do you deal with thermal bridging or whatever the topic happens to be, but then there's a discussion. And what I found is that the person that writes the article actually responds to those discussions. And so I found that to be a valuable place to go, and it's pretty inexpensive to be able to get to the full articles and the full discussions. And they all, like you say, they also have a big library of articles that they've written on specific topics or videos and all these kinds of things. For sure. And Dan, do you have any other thoughts or?
No, I really like Joe Stiebrick's stuff. I agree with you. He's turned into realist, and he admits when he has done things wrong and he corrects himself, and it's really refreshing to see that. And so I've been following him like my whole career, and Building Science Corporation has got a lot of great articles on their website. And yeah, the fine home building thing too, it is great. I really like a gentleman called Allison Bales. I follow him quite often, and he's a little, maybe a little opposite of Joe in a way, but he does a lot of actual in the field testing and makes videos and shows you. And then the other person I guess I follow a lot is an architect called Steve Basic. Up in Minnesota, and he's really about his details and making sure things happen. And we do a lot of work up in Minnesota, and it's building in a whole different place. So, you know, they have different, it's colder, they need to do it up there, but they also just have more products, and all this type of work is normal in the industry. It's slowly migrating down here, and I can see it happening in Iowa. So if you're about Ames and north, we're kind of getting it.
Well, good. Well, I appreciate you guys taking your time to do this. It's very valuable for me. So, excellent.
I'd say thank you for asking these questions. I mean, just the fact that we're having this conversation, it's kind of a joke, ask 3 architects, we get 4 opinions. So
Yeah, exactly.
This is wonderful, and I'm happy to.
Now, Mike will tell you it's also true of beekeepers.
True.
Mike is learning to be a beekeeper, and it's true of beekeepers as well.
I'm a better architect.
Yeah.